Okay, thank you, Silvia. I will now show how to put together the other pieces of the puzzles to develop a candidate with improved probability of success. And we'll start from one of the major aspects related to the development of a peptide therapeutics, which are those related to ADME. ADME tools that need to be developed to address specific issues which are typical to peptides as a class, and help designing candidates with improved half-life and bioavailability. Peptides usually present some challenging ADME properties, such as limited metabolic stability, poor oral bioavailability, and short half-life. Early preclinical in vitro studies, such as plasma metabolic stability assays, are crucial to improve the process of development of peptide drugs. To speed up the optimization of peptide metabolic stability and limit the number of resources used, an efficient bioanalytical method was developed. This method is ideally combining a quantitative determination of metabolic stability and a qualitative identification, structural elucidation of metabolites in preclinical plasma samples, using a combination of liquid chromatography and high-resolution mass spectrometry. High-resolution MS data were simultaneously acquired both in positive full scan and MS acquisition mode, and then processed to allow simultaneous identification of plasma half-life and identification of the major metabolic cleavage sites. Positions that are in the need to be modified to increase metabolic stability are thus immediately identified, and chemical strategies to derivatize or single point mutate the peptide sequence to stabilize the metabolic soft spot can be introduced already in the next synthesis cycle, affording peptides which are metabolically stable and have prolonged half-lives. This method was developed for the evaluation of in vitro plasma metabolic stability of peptides, but can be applied also to other in vitro metabolic stability models, such as whole blood or hepatocytes. The understanding of metabolic liabilities is of utmost importance to optimize the ADME properties of peptide. But an important aspect to underline here is that when the optimization is done on peptides containing lipids as half-life elongation moiety, the presence of the lipid and its binding to albumin can prolong the half-life of the peptide by diminishing its renal filtration, but do not necessarily protect the peptide chain from metabolism. So meta-ID identification has to be run also on lipidated peptides. Okay, optimization of ADME properties of peptides needs to account also for factors beyond their stability in plasma. As a matter of fact, the increase in metabolic stability does not always confer to the peptide a good bioavailability. In the case of subcutaneous injectables, bioavailability can be hampered by catabolism at subcutaneous tissues, which is in turn influenced also by aggregation properties of peptides for medium-sized peptides, or partial absorption through lymphatics for bigger peptides. In the case of orally administered peptides, bioavailability can be hampered by metabolism in the gastrointestinal tract, and also by a major aldol for the peptide when administered orally, which is the absorption through the intestine. So for the overall improvement of ADME properties, it is important to focus on site-specific metabolism depending on the route of administration, and to early develop in vitro assays capable to predict this metabolism. In the case of subcutaneous peptides, a predictive model for catabolism at subcutaneous tissues, which enables to build up in vitro in vivo correlation, would speed up the optimization of the peptide and reduce considerably the number of in vivo studies. In a similar way, for peptides aimed to oral delivery, an early implementation of in vitro assays to understand the stability of peptides versus proteolytic enzymes present in the GI tracts allows to work with stable peptide and be in a better position to start studying how to overcome the big hurdle of intestinal absorption and the effect of the use of permeation enhancers. As an example, I will show how for the sub-Q administered peptides during one of our research programs, we had evidence for a formation of a specific metabolites which was generating only at the injection site. Upon subcutaneous injection, a considerable amount of metabolite 8 was detected. And this metabolite